Okay, so neutral atoms have the same number of protons and electrons, right? So neutral meaning there is no net charge on that particular atom. A charged atom is what we call an ion, and ions are formed when an atom either gains or loses electrons. So that atom will never change the number of protons in the nucleus, but it can change the number of electrons. So when we lose an electron, for example, a common ion is the sodium ion. When the sodium atom loses one electron, it becomes the sodium ion. It is a positively charged ion, and we call it a cation. When an atom gains electrons, such as chlorine can gain one electron to become the chloride ion, and we say that it is a negatively charged anion. Molecules also have the potential to lose electrons, and those are examples of what we call polyatomic ions, and we'll talk more about those at a later time. But basically, let's stick with some simple examples like the sodium atom. So the sodium atom has an atomic number of 11, therefore there are 11 protons in the nucleus, and for the neutral sodium atom, it also has 11 electrons surrounding that nucleus. We can undergo a process of oxidation or ionization of the sodium ion by removing one of those electrons. And so when sodium loses a single electron, it becomes the sodium ion with a +1 charge. Okay, because now there are more protons. There are 11 protons in the nucleus, but now only 10 protons in the nucleus and only 10 electrons associated with that ion. So it has a net positive charge. Chlorine, on the other hand, has a tendency to form anions. That is, it has a tendency to gain a single electron. So the neutral sodium atom has 17 protons in the nucleus and 17 electrons, and when it gains one electron, it forms the sodium ion, which now has one more electron than it does protons, and so it has a net -1 charge. And we would say we now have the chloride anion. Now, in general, ions that are formed can be predictable. So, for example, metal ions have a tendency to lose electrons, a process we call oxidation. So whenever a metal loses electrons, it will have a net positive charge. That is, it forms cations. Nonmetals, on the other hand, have more of a tendency to gain electrons, and therefore they tend to form negative anions, negatively charged anions. So the number of electrons that an atom loses or gains will tell us what the charge of that particular ion is. Now, many of our common monoatomic ions have a charge that is easily predictable based simply on the position in the periodic table. And while we'll have a more in-depth understanding of this relationship between the position in the table and these predicted charges, for now we pretty much just need to remember that the periodic table can be used as a guide. So we look here in period 1A. These are the elements that we call the alkali metals, right? Notice that the charges on all of these ions, and these are the only cations formed by these, especially these metals only form cations, they all are a +1 charge. So group 1A means we have a +1 charge. Group 2A, or alkali earth metals, all have a +2 charge. So magnesium and calcium and strontium always lose 2 electrons to become a +2 cation. Our period 3 metals, of which aluminum is really the only really important member, notice that group 3 has a +3 charge for this metal aluminum. So aluminum in a compound will always have a +3 charge. Then we come to our nonmetals, and remember, nonmetals have a tendency to gain electrons. So we start here with the halogens being our most common example of a non-metal monoatomic anion. These, notice, all have a -1 charge. So fluoride and chloride and bromide and iodide will only have a charge of -1. Similarly, our group 6A here, which we call the chalcogens, these always have a -2 charge. And then we have nitride, and not shown here as phosphorus, will typically have a -3 charge when in binary compounds. So the position of the table makes it really easy to predict what the charge for these ions are. Now, our transition metals also have a tendency to lose electrons, becoming positively charged. However, the charge varies quite a bit throughout this group, and there are no really simple uh, rules that are going to help us to predict this, but we'll worry about that in a little while. Now, once we know the charge of an ion, this allows us to predict the formula of the ionic compounds that it will form. And we do this by recognizing that an ionic compound, it has a net neutral charge. That is, the positively charged cations must exactly balance the negatively charged anions. And our simplest example would be something like sodium chloride. Okay, so sodium chloride is table salt. That is bringing together a +1 sodium ion and a -1 chloride ion, and that gives us the neutral compound, the neutral ionic compound, sodium chloride. That is, they come together in a 1-to-1 ratio, 1 sodium ion and 1 chloride ion. If instead of sodium we had magnesium, an alkali earth metal, because magnesium here has a +2 charge, in order to maintain electron neutrality, that is to form a compound with a 0 net charge, we need to bring 2 of the chloride ions together with the 1 magnesium. And so the magnesium chloride as an ionic compound has the formula MgCl2. So 1 magnesium ion and 2 chloride ions. And it's this association that in fact will allow us at a later time to predict the charges of our transition metals. So to form an ionic compound, we bring cations and anions together in such a way that there is a net neutral charge.